Welcome to lecture 15 of financial risk management. We had started our discussion on the determination of forward and future prices, and we are going to continue that topic in this lecture. Moving towards the contents, in previous lecture we had the basic concept of forward pricing or future pricing. And then we saw a model where we determined the price of or estimated the forward price when we had an investment asset, and within the investment asset, the asset was a non-income paying investment asset. So that is the basic model of determining the forward price. In this video, we are going to explore how to determine the forward price if the investment asset is an income paying asset. And next, we are going to understand that even if it is an income paying asset and instead of the income in dollars amount, we have the yield, the percentage yield, how we are going to find the forward price. And there would be a slight change in the method of estimation. So first, starting with the income paying investment asset, the calculation of forward price of income paying investment asset. When we say income paying investment asset, then it can either be dividend or interest that we would receive. So we find the formula is F naught, which is the forward price. So naught means today, the present forward price. We want to determine the forward price. We had been determining it for last two lectures. We are discussing this concept. The idea is that it would be S naught minus I. I is the present value of all the incomes that are generated from that specific asset. But we have to find the present value using the continuous compounding method we discussed in previous lecture. Multiply by E, which is a constant term, raised to power R, which is the risk-free rate, and T, which is the time period. So in previous, we used this formula, F naught is equal to S naught into E raised to power RT. But now we are going to deduct the present value of the investment. And because the forward contract holder do not receive dividend or interest on the underlying asset, they just receive the S naught. So therefore, the present value of those components would be deducted from the S naught while we are calculating the F naught. So again, the strategies would be, if the forward market is greater than forward intrinsic, we have a detailed discussion on this in the previous video, and if you haven't watched that, go back and watch that lecture. These strategies are discussed in detail with an example. So arbitrager can buy the asset and short the forward contract to earn profit. Remember, we are discussing arbitrager, how arbitrager would earn profit if forward market is greater than forward intrinsic. And in the previous formula, what we are going to determine is we are going to estimate the forward intrinsic. The forward market will already be observable. It will be the market price. And if the forward market is lesser than forward intrinsic, the arbitrager can earn by short selling the asset. It is not the short forward contract. But short selling the asset and entering into the long forward contract to earn profit. So if we move towards the example, consider a long forward contract to purchase a coupon bearing bond. Now when we say coupon bearing bond, we know that there are two types of bond. One is a zero coupon bond and one is coupon bond. Zero coupon bond do not pay any coupon, and when we see zero coupon bond, it is a non income paying investment asset, and the formula we would use is S naught into e raised to power RT. But what if that investment asset is an income paying investment asset? There is a coupon. The coupon means that if the interest amount, if there is an interest amount, then we know that it is a coupon bond, and it is an income paying investment asset. So from this term coupon bearing bond, we quickly get an idea that it is a income paying investment asset. So hence we are going to use the formula that we just discussed in the previous slide and not this one. So the current price is 900. This is our S naught. We will suppose that the forward contract will mature in 9 months. This is our T, but there would be some complication and you would see in a while. We will also suppose that a coupon payment is 40. Okay, this is the coupon payment, but it is not I, because what was I? The present value of this coupon payment. So we need to find the present value of this coupon payment. So when we will get this $40, we would have this $40 after 4 months. We assume that the 4 months and 9 months risk-free rate, which is continuously compounded, is 3% and 4% per annum. So we had been given two different risk-free rates, and I will tell you in a while why there are two different rates. So if a contract or if we are going to receive interest or it is going to mature, the contract is going to mature in 4 years, then we are going to use this interest rate, and if it is going to mature in 9 months, then we are going to use this interest rate. So there are different interest rates for different maturities. So for 4 months we have 3%, for 9 months we have 4%. Moving on to the solution, first we need to calculate the value of I, and the value of I is the present value of the coupon payment. Remember, coupon payment was how much? $40. Normally, how do we find the present value? The formula of present value is PV is equal to FV divided by 1 plus R raised to power T. Now we can write the same present value formula in one more way. Normally we are not used to saying it like this, but this would be FV into 1 plus R raised to power minus T. They both are same formulas. They both give the same result. But in case of our forward pricing or derivatives, we said that we are going to use continuous compounding instead of compounding for a specific frequency. So when we are going to use continuous compounding, then we are going to use E. So this formula would turn out to be FV divided by E raised to power T, and this would be FV into E raised to power minus T. Sorry, I missed the R here and here. So now whether we use this one or this one, they both are similar. Okay, so once we have understood this, it would be easy for us to understand this equation. This equation is nothing but we are going to find the present value. So FV into E raised to power RT minus. So this is how we have written it. We can use this convention, but I am moving forward with this one to be consistent with the books that we are following. So this is how our textbook uses it. So I'm going to use it in the same fashion so that when you go through the books, you have an idea that what this means. So the future value is 40. We are going to receive this 40 interest rate amount after 4 months. In previous slide, we had two interest rate. One was 3% and other was 4%. The 3% was 4 months, for 4 months, and the 4% was for 9 months. So because this interest rate is going to be received after 4 months, we are going to use the interest rate of the 4 months, which was 3%. So the interest rate was 3% or 0.03 minus sign as in the formula into number of months divided by 12. This would give us the value of 3.96. This is the present value of the interest amount that we would receive after 4 months. Okay, now we need to put this value into our formula, and our formula is F naught is equal to S naught minus I was the present value, we just calculated it, into e raised to power RT. So S naught was 900 in previous slide. In the example, we just calculated the I, e raised to power 0.04. So instead of 0.03 interest, we are going to use 0.04, but because remember this contract is going to expire in 9 months and the risk-free rate for 9 months was 4% into 9 months, because this contract is going to expire in 9 months divided by 12. Why we are dividing it by 12, I hope I have explained this. Because this interest rate is per annum, but this contract is going to expire in 9 months. So we are going to earn this full 4%, rather we are going to earn 9 by 12 of this 4%. The answer we would get would be 886.60. So this should be the forward price. This is the intrinsic forward price. If the forward market is greater than this, then we would use a strategy that we have discussed, one of those two strategies. And if this forward market price is lesser than this intrinsic value, then we would use another strategy, and we have already in detail discussed those strategies. So moving on to another example, consider a 9 months forward contract, 10 months forward contract. And when we say 10 months forward contract or 9 months forward contract, this simply means that this forward contract is going to expire in 10 months. If you visit the website of Pakistan Stock Exchange, you would see that there are certain stocks, those stocks do have a forward contracts, or future contracts rather, I would say, because they are traded on exchange. So you would notice that, say for example, if you are going to check the future contract in Pakistan Stock Exchange website for Lucky Cement, you would see something like this, September, or it would be written as August. This simply means that this specific future contract is going to expire in September, and this specific future contract is going to expire in August. And I would recommend you that you visit the website and see how things are, just for an idea. So consider a 10 months forward contract of Nishat Mill Limited. This is a stock that is listed on Pakistan Stock Exchange. The price is 50 rupees, hypothetical price. This is S naught in our case. Assume that the risk-free rate of interest continuously compounding is 8% per annum for all maturities. So whether it would mature in 3 months or 4 months or 5 months. In previous example, we had different interest rates, but in this case, we have a single interest rate, and that interest rate would apply for all maturities. Also assume that the dividend is 0.75 per share expected after 3 months, 6 months and 9 months. That means that we would get a dividend of 0.75 once after 3 months, then after 6 months, total of 6 months, and then after total of 9 months. So we have 3 dividends. Now again, we now know that it is an income paying investment asset, right? So what strategy would we use if the forward rate is 53? We would come back to this one, but first we need to understand, we need to find out the intrinsic value of this stock. So again, the same formula, the forward price of the contract. First we need to find the I. But in this case, in previous example, we only had one interest rate amount or the one income. In this case, we are going to receive 3 dividends, whether of similar amount or different amounts, it wouldn't matter. You would have to just change the dividend amount. So we need to find the present value of all these dividends. We can either find the present value of one, then second, then the third, and then add them up, or we can simply write it as in this equation. So first dividend is 0.75 into E, again the same formula, raised to power 0.08, this is the interest. Remember we had 8% interest for all maturities, into 3 by 12. So this would give us the present value of the dividend that is due in 3 months. This part would give us the present value of dividend that we would receive in 6 months. This would give us the present value of the dividend that we would receive after 9 months. If we add all these up, we would get a present value of dividend of 2.169. This is the present value of all those dividends that we would receive. We put that in this formula, S0 minus I raised to power 8% into 10, because this contract will mature in 10 months, and we get the price of 51. So in this case, forward market, which was 53, we saw in previous slide in the question, forward market is greater than forward intrinsic. So if forward market is greater than forward intrinsic, what do we do? This strategy is what we are going to follow. We are going to buy the asset, the stock, and we are going to enter into a short forward contract, and by following this strategy, the arbitrager would be able to earn a riskless profit. Okay, there is one more scenario when instead of the amount of interest or whatever the income component is, instead of it being in rupees or in amount in dollars, if it is in percentage, then what would do? So when the asset underlying the forward contract provides a known return which is in percentage rather than the known cash amount, so instead of deducting the amount from S0, we are going to deduct the average value of the income from R, from the risk-free rate. So this is how we would modify the formula. This is our example. Consider a 6 months forward contract on an asset that is expected to provide an income of 2%. Now you would see that the income, instead of being in rupees or dollars, it is in percentage of the asset price once during 6 months period. So the income would be 2% after 6 months. The risk-free rate of interest with continuous compounding is 10%. The asset price is 25. This is S0. What is the forward price, or what should be the forward price of this contract? So this is our formula. The S0 is 25, E raised to power risk-free rate, which was 10%, minus the 2%. So we are going to simply deduct the percentage from the interest rate. So if we had multiple percentages, so we would simply take the average of all those percentages into 6 by 12. Why 6 by 12? Because this contract would mature in 6 months. And it doesn't matter when we are going to receive, because we do not need to find the present value. Okay, the answer would be 26.02. So the forward intrinsic price would be 26.02. So we have covered the the case of investment asset, and next video we are going to consider the consumption asset and some other discussion within this chapter.